In our next example, they ask us to find the points at which the graph of the equation has a vertical or horizontal tangent line. So we know that there's going to be a vertical tangent line when the slope is undefined. And we know there's going to be a horizontal tangent line when the slope is equal to 0. And we know that we find slope by finding derivatives. And in this case, to find the derivative, we're going to need to use implicit differentiation. So in this one, I'm going to do something a little bit different. Instead of dy dx, I'm actually going to use the y prime notation. It's a little bit of a risk because while it's quicker to write, if you're not careful with your handwriting, the y might look like a y prime and vice versa, and you really have got to be very clear. So here we go. 8x plus 2y y prime minus 8 plus 4y prime equals 0. These are both constants and the derivatives are 0. Having our dy dx party or our y prime party, we end up getting 2y y prime plus 4y prime is equal to 8 minus 8x. Factoring out the y prime and dividing, we get 8 minus 8x divided by 2y plus 4. On the top, I could every one of these things can divide by 2, so I think I'm just going to go for it. 4 minus 4x is equal to y plus 2. So here's an expression for the slope of the tangent line. Now we want to see where that expression is undefined. Undefined, think denominator equals 0. That's where things are undefined. So I'm going to say y plus 2, which is the denominator, is equal to 0. So I think it's going to be undefined when y is equal to negative 2. Okay. Now, slope is going to be equal to 0 overall if the numerator is equal to 0. Numerator equal to 0. 4 minus 4x equals 0. 4 equals 4x. X equals 1. Now the question, if we look at it again, it says find the points. So they probably want an ordered pair. So what I think I'm going to need to do is plug these in to get the corresponding x or y value. So let's do that. So for the first problem where y is equal to negative 2, I'm going to say 4x squared plus negative 2 squared minus 8x plus 4 times negative 2 plus 4 is equal to 0. 4x squared plus 4 minus 8x minus 8 plus 4 is equal to 0. 4x squared minus 8x. Now notice I've got a plus 4 and a plus 4, which is 8, and 8 minus 8 is 0. So the constants all go away. And if I factor out a 4x, I'm left with x minus 2. And if I set each of these factors equal to 0, I get x equals 0, x equals 2. So I think there are going to be two places where we're going to have an undefined slope or a vertical tangent line. One of them is going to be at 0, negative 2, and the other is going to be at 2, negative 2. Okay, now over here we're going to have to do the same sort of thing, and I hope I have enough room for it. 4, now I'm going to plug in 1 for x. 1 squared plus y squared minus 8 times 1 plus 4y plus 4 is equal to 0. 4 plus y squared minus 8 plus 4y plus 4 is equal to 0. Now the same thing that happened with the constants over here is going to also happen over here. 4 plus 4 is 8, 8 minus 8 is 0. So we're really just left with y squared plus 4y is equal to 0. If I factor out a y, I'm left with y plus 4. And again, I'm going to get two answers. Y equals 0, y is equal to negative 4. And this is for the case when x is 1. So my possible answers are going to be 1, 0, and 1, negative 4. I thought some of you might be curious as to know what the graph of this looks like and to sort of convince ourselves that these are the locations where we have a horizontal tangent line and a vertical tangent line. So to do this, we're going to need to complete the square, and here's the ellipse, or the oval, however you want to think about it. All right. So we said there's going to be a vertical tangent line at 0, negative 2, which would be here. And you know what? That absolutely makes sense. There's going to be another one at 2, negative 2. 2, negative 2 is here. This also seems very reasonable to me. Now we're going to have horizontal tangent lines at 1, 0. I'm buying it. And 1, negative 4. So this sort of, to me, just validates our answers, and after doing such a rigorous problem before, it just makes sense, and I'm pretty confident that we're correct. In the next example, we're going to be using implicit differentiation in a trig function. We're asked to find dy dx for x cosine y equals 1, and then to evaluate the derivative at the specified point. This to me looks like it's a product rule, so we'll set up let's see, let's pick a pen color here. Let's do f, f prime, g, g prime. The first function is x, its derivative is 1. The second function is cosine of y. The derivative of cosine is negative sine. So it's negative sine y, and then it's going to be y prime, or dy dx. The product rule is the first times the derivative of the second plus the second times the derivative of the first. So we're going to have the first times the derivative of the second plus the second times the derivative of the first. And then the derivative of 1 is just 0. So I'm going to rewrite this as negative x sine y, y prime, is equal to negative cosine y. Y prime, when isolated, is going to be negative cosine y over x, negative x sine y. The two negatives are going to cancel out, so we have cosine y over x sine y. So this is our derivative. This is our expression for the slope of a tangent line at a given point. And the point now they're giving us is 2 and pi over 3. So this is going to be the cosine of pi over 3 over 2 times the sine of pi over 3. The cosine of pi over 3 is 1/2. The sine of pi over 3 is root 3 over 2. These are going to cancel out. So we're going to be left with 1 over 2 root 3. if you decide to rationalize that, you end up getting root 3 over 6. So this is dy dx for the function, or for the equation x cosine y equals 1 at the point 2 pi over 3. In our final example, they ask us to find the equations of the tangent lines and the normal line to the circle at the indicated points. The term normal line might be new for you, but it just means perpendicular. So whatever we find as the slope of the tangent line, we're just going to take the opposite reciprocal to find its perpendicular counterpart. So let's start by taking the function and finding its derivative. X squared plus y squared is equal to 9. Differentiating implicitly, we're going to get 2x plus 2y y prime is equal to 0. 2y y prime is equal to negative 2x. And y prime is going to end up equaling negative x over y. For our first point that we're going to plug in 0 for x and 3 for y. And that's going to get us negative 0 over 3, which is just 0. So that means our equation is going to be y minus 3 is equal to That means our equation is going to be y minus 3 equals our slope 0, x minus 0. And cleaning this up, it just turns out to be y equals 3. Now, if I were to look at the point 0, 3 and look at the tangent line, if I were to actually draw it myself, it would look like this. And that's the line y equals 3. Now if I want the normal line, that would be the line that's perpendicular to this one, it would just be x equals 0. X equals 0. So this is our tangent line and this is our normal line. Now we've got to take this derivative and we've got to do the process again for the other point. So I'm going to make some room over here. Now the other point is going to be when x is 2 and y is root 5. So we get negative 2 over root 5. So our equation is going to be y minus root 5 is equal to negative 2 over root 5 times x minus 2. That will be the equation of the tangent line. Now if I want to find the equation of the normal line, I'm going to have to take the opposite reciprocal. Not really a big deal. This is going to be negative root 5 over 2, x minus 2. So our first equation was for the tangent line, and our second equation was for the normal line.